Good afternoon, everyone. Thank you for joining us. I'm Kenya Desatel, a COPA board member and chairperson of the Education Committee, and I'm really pleased to welcome you to our first webinar of 2022. For those of you joining today that are not familiar with COPA, our association advocates for the O&P profession at the state level in California. And as an organization, we are focused on providing relevant and unique information to positively impact our members and the California O&P community. 2021 was quite the successful year for COPA. One of our top priorities has been to increase the Medi-Cal fee schedule, and in 2021, we organized 6 facility tours with state legislators. This was a major step in that plan to bringing understanding and awareness to those legislatures, many of which have little knowledge of our profession, let alone all of the difficulties our patients have or can have trying to get access to care and proper devices. In 2022, we plan on building upon this progress and submitting a budget proposal and drafting legislation to improve the Medi-Cal fee schedule here in California. We have an updated website which has a members only feature which further adds to the benefit of being a COPA member. It includes access to recordings of all of our past webinars, archived COPA Connection newsletters, and information our reimbursement committee works so hard to consolidate and provide just to those members. In 2021, COPA saw one of the largest memberships to date, with over 40 companies and individuals recognizing the importance and the value that we bring to our community. And in October, we got to host an in-person symposium at Pacific Medical in Tracy. There's approximately 100 people in attendance, 17 exhibitors, and an array of unique presentations that we offered. A few highlights were a panel discussion, happy hour, and dinner, which were sponsored by Pacific Medical, and an engaging conversation from AOPA's Ashley White. So as you can see, COPA continues to work hard for our members and the O&P community here in California. We truly welcome your involvement and feedback to further our efforts. So please regularly check our website, californiaonp.com, for updates and upcoming events. Now, the exciting thing, what you all came here for, I would like to welcome our host, Fernando Grego, an applications engineer with Hewlett-Packard. And he will be leading our discussion today. So please submit your questions via the Q&A feature in Zoom. They will be answered at the very end of the presentation. Fernando and our panelists, thank you for sharing your time and your expertise. And I will pass the screen along to you.
Perfect. Thank you, Kenya, for your introduction. Hi, everyone. This is Fernando Grego. I'm application engineer at HP. And first of all, I'd like to thank you all for joining us. On the agenda for today, I will start with a quick overview on 3D printing, HP technology, and O&P applications. Then we'll have some time for the panelists to introduce themselves and talk a little bit about their company. And after the panelists' introduction, we'll start the panel and have a round of Q&A at the end. So you can submit any questions that you'd like us to answer on the Q&A on the Zoom section. So starting with the 3D printing overview, there are many additive manufacturing technologies in the market today, and usually those technologies, they are divided or separated between material type and energy source. And HP's technology, called multi-jet fusion technology, is a powder bed technology, and we produce plastic parts. Talking a little bit about how the technology works, so we have 4 basic steps. In the first step, on the first one, the HP inkjet print heads apply liquid agents drop by drop across all the bed, across all the building platform. And we have 2 different agents during that we apply during this step. So we have a fusing agent and a detailing agent. The fusing agent defines the area of powder to be fused, and then the detailing agent helps to get a good part accuracy. So after the powder bed, after we drop the agents, the powder bed is heated using infrared light, and then the agents are fused, creating our part. As soon as the fusing layer is finished, the next layer of powder is recoated in the printing bed, and then the same steps are repeated layer by layer until we have our full part manufactured. We have a quick video here showing how the machine works. So this is for our MJF 4200 printer. We see that we have two main components. So the first one is the print and the fusing carriage, where we have the agent drop and then also the infrared lamps fusing the agents. And then we have the recoater spreading material for the following layer. Now, talking a little bit about OMP, let's first take a look at the traditional process. So traditionally, it's hard and laborious to create highly customized parts. In addition, may be a little bit uncomfortable depending on the process that we are using. Can be uncomfortable for the patients to get the impression and this part of the plaster process. And with 3D printing, especially with multi-jet fusion technology, HP is bringing back the blacksmithing creativity. So we are enabling the production of complex geometry like lattice structure, reducing weight for some parts, increasing breathability, among other benefits. In addition, MJF is highly recommended for customized products, mainly focus on the perfect fit in order to guarantee the best performance and improve the patient's life quality. So bringing back the blacksmithing creativity, with our printed parts, we can enable amazing experience for patients, and also being a more economical option for hospitals, clinicians, and doctors. Now, talking a little bit about the digital workflow, let's trace a parallel between the traditional process, the traditional workflow, and also the digital workflow. So on the first step on the current process, on the traditional process, is to get the impression using plaster. So this process, especially when we are talking about children and even babies, could be a little bit challenging and even uncomfortable. Besides that, the impression process is also susceptible to human error. When we are using the plaster, the patient may not be relaxed, an arm or leg may not be in the right position, the patient can move a muscle, for example, and that could cause some issues on the final part, for example, having a not good fit. So considering some of all of the process for the traditional manufacturing, the total manufacturing cycle may take up to 2 weeks or even more. And also, it's hard to go backwards and fix potential errors that we had in the initial of the process. So the current process, some of the needs, customization, reduce lead time, having a more accurate process, and also having a gentler methods for patients, especially when we are talking about children. So comparing this to the new process with the digital workflow, the first step for the digital workflow is the scan. This is a really fast and patient-friendly process, and also way less susceptible to errors if we compare with the traditional process. Then using some CAD software, we can change, customize, create lattice structures, and make sure that we have a good part ready to print. There are a lot of softwares focused on the medical industry, and then after we have our part created and our part finalized in the software, using our multi-jet fusion printers, you can have your parts done in a matter of the same day or the very next day. Okay. Now some quick examples to start before our panel. We'll discuss more examples during the panel, so I'll be brief here. First example, MJF is great for insoles. We can have localized stiffness in certain regions. We can relieve stress in specific areas if needed. Another example, we have AFOs, where we can produce parts much lighter than the traditional parts. and we've optimized the design and also reduced the material usage as well. In the case of cranial orthosis, customers using our technology, they are now capable to consolidate parts that before they have 2 or 3 different parts, they can consolidate in a single one, improving the performance and also increasing breathability, so providing more comfort to the patient. Another example here before we start the panel and start the intro to our panelists is the prosthetic sockets, where the comfort for the patient is also enhanced, especially removing the plaster, the impression process. And we can also reduce the lead time drastically for this process. So this was just a quick interview, a quick introduction to our process, to some examples on multi-jet fusion on the O&P industry. And now I'd like to start the round of introductions from our panelists, with Sean from Quorum Prosthetics.
Hi everyone, my name is Sean McClure, lead engineer, biomedical and mechanical engineer at Quorum Prosthetics. I developed the digital workflow for our patented Quattro prosthetic socket technology. And we've been printing in-house for the last year, but have been utilizing multi-jet fusion printing for the last 2 years roughly. And we this Quattro socket has 4 zones of adjustability and compression, and so the design is really complex, and we can kind of talk about it later in the panel.
Thank you, Sean. Now I'd like to call Diana from ActivArmor.
Hi, I'm Diana Hall with ActivArmor. We do custom 3D printed casts and splints for any body part. It's done with a digital scan using an iPhone. It's available to anyone across the country and even across the world. And we partner with clinics and O&P shops, physical therapy, and stuff like that to bring these casts and splints to everyone so that they can have custom waterproof, breathable options that allow you to wash and sanitize your hands during the COVID pandemic, which is really important. It's also great for people with diabetes and foot ulcers and things where you need to just be able to be hygienic. And so this custom alternative gives you a product that is reusable and also hygienic and lets you just swim, bathe, and shower like you normally would. So that's what we do.
Okay, thank you. And then now Antonio from Hanger.
Thank you. I'm Antonio Diaz. I'm the Director of Engineering for Hanger. I oversee our 3D scanning, 3D printing, and some of our quality and regulatory affairs. Part of that, I oversee the implementation of our digital workflow. One major benefit of that here at Hanger is we have such a large clinical team. It allows us to work and quickly design new devices for our patients. A lot of necessities is identified here, and as the old saying goes, necessity is the mother of all invention. So it's really good to have these tools, be able to 3D print something, conceptualize it, design it, and have it turned quickly for our patients.
Great. So now that we had a first round of introduction, we can actually start with the panel. Thank you all the panelists for the intro, so our attendees can understand a little bit more about your role and then about your company. So my first question to all of you is, considering that we are comparing the digital workflow with the traditional workflow, is where you are on your journey on the adoption of the digital workflow, and especially understand what were the challenges during this adoption. And we can start with Antonio, and then we can go with other panelists on the other questions.
Yeah, thank you. So for us, we had to start with the input. How do we get the tools in all of our clinicians' hands to take those scans and get a workable file that we could use? Once we did that, it was understanding, how to truly use this technology to benefit the patients. We weren't just doing something because we could. We wanted to do something that truly was better and effective for our patients. We reviewed a lot of different technologies, 3D printing technologies, to see which one would work. We did ISO testing on our devices to see if they were strong enough and safe enough. We didn't want to put anything on a patient that wasn't safe. So I think for us, it was the long journey of identifying all the right software, all the right tools, and putting it in the hands of our clinicians.
Okay, good. Nice perspective. And then, Shan, what were the biggest challenges, some challenges, and then where are we on your journey right now?
Yeah, so some of our biggest challenges early on was, adopting the scanning, finding, an accurate scan, processing that data properly, and then being able to, fully customize our prosthetic devices in CAD. And we also kind of researched and looked into and evaluated multiple different technologies for printing, and ultimately landed with HP. And so we kind of started out prior to, so in the latter half of 2020, we were outsourcing a lot. So all of our digital designs and things we would outsource to different partners that printed with HP, kind of evaluated the final product, made some design iterations, things like that. And then beginning in January of 2021, we acquired our own equipment so that we could bring the printing and fabrication in-house and iterate more quickly, and get a cheaper per part production by printing in-house. And so we've been printing for the last year, and it's been really successful, and we've been able to iterate different designs and even other products very quickly.
Okay, great. And Diana, what's your comments on the challenges on the adoption of the workflow, and also talking a little about your journey and ActivArmor journey now?
Sure. So right now we're at the point where we have two processes. We can provide direct to consumer, which means that we have to have a package technology-wise that is easy for any consumer to pick up and use. So the fact that it's available on their iPhone to do the scan, to have the process in place where they can pick up their iPhone and without any training be able to do a scan that will give us the precision that we need to be able to make a device that will fit them and immobilize them, which is so important during fracture care. And to be able to have that package be turnkey enough that anyone can use it and make the whole entire provider package simple as well. Because when you are selling to O&P shops and hospitals, they need to be able to have a footprint of the entire fabrication process that is plug and play. They don't want to be having a lot of staff time and labor and everyone learning how to do CAD design and all of those things. It's a package deal between the scanning hardware and software, the design, custom design hardware and software, and then the manufacturing, the 3D printing hardware and software, as you know. And so when we package that all together in a bundle and make it turnkey and plug and play, that's really, I think, the key to marketing well to any provider, and then even going one step further and going direct to patient with a telehealth type of scenario where we have an ortho tech that's on staff. So now providers can even just write a prescription and the patient can get fitted and treated through telehealth ortho techs now during the pandemic and everything, when it's really hard to be able to travel to and from your doctor and it's risky and stuff. So we are really trying to be sensitive to the changing needs of our customers.
Oh, that's great. And based on your comments right now, Diana, is there any specific success case that you want to share where you wouldn't have problem with the traditional process and then the digital workflow improved your customer experience, so made you possible for you to support a customer and attend their needs?
Yes, absolutely. So before, when we first started this whole thing back 6 years ago, and we would have these very expensive scanners that we would have to train the staff on and place in a hospital, and it would be a very front end loaded labor type of sales process, and it required a lot of skill and expertise and travel for us and everything. And so we would only go into major metropolitan areas with lots of volumes of fracture care and stuff, and we weren't able to help the people who really needed to get their hands dirty. They were working on the ranch or on a farm, or they were in rural areas and really needed this product. And so now through the whole digital workflow, we are now able to have anybody who has access to an iPhone be able to do the scan right there in their own home and get fitted there in their own home, and then just have their local doctor just check it, whether or not their doctor is a partner as an ActivArmor provider or not. And this allows us to reach out to clinics who are interested in doing it, who may not have a huge high volume of fracture care, or even a PT clinic or an athletic training office or whatever. Now they can provide fully custom, the next gen products and digital. This is awesome for athletes, right? So NFL players, etc. They're all able to offer these products to their patients without all of that expense and infrastructure and learning and space and all the things that they used to need. So.
Okay, that's great to hear all of those benefits. And Antonio, is there any success case that you'd like to share about how the workflow, the digital workflow improve it? And also, I'd like to get your perspective on, based on the workflow, if considering that Hanger has many clinics all over the US, if all Hanger clinics have access to the 3D printed devices, and how does that work?
Yeah, of course. So with our digital workflow and these 3D printed devices, we've noticed a pretty big increase in first fit success. So we'll see a patient, we'll be able to get that scan, and that first device with the digital tools and the digital workflow, we can get a device that, we can mirror a sound side and get a bioidentical shoulder disarticulation socket or whatever it may be. We can get it so perfect in CAD that when we print it and we fit it to the patient, it works really well. Replacements are huge for us. We had a patient, lose a hand. We were able to print a new one and overnight it the next day because we had that digital file and we knew that file worked initially. For our clinicians, any Hanger patient can go into any one of our Hanger offices and get a 3D design device. And so we're starting to roll out catalogs of devices we offer regular. So we have certain products that, it's a known product. We also do a lot of prototyping. It's great because we'll fit a patient and, I can have a clinician do a screen share with me and say, that device worked, but I would like 3 degrees of rotation. There's been several instances where we've slightly rotated something and on screen they say, I don't think that works, but I measured it, let's go ahead and do it. And it comes out perfect. So that precision and those types of tools are something that we have historically not had, but we have now, and it really makes a world of difference for the fits we see and the satisfaction our patients have.
Oh, that's great. And Shen, could you share some success case where the digital workflow improved the customer experience at Quorum?
Yeah, of course. So yeah, along the same lines as Antonio, we have a lot of success with keeping digital records of each design. If the patient has a minor change, we have those digital records. We don't have to start from square one and restart the whole fitting process of casting and doing all that again. Or because with the scanning, we can scan the original mold. If something changes, we can tweak it digitally. We have each iteration, each version, and so that increases or decreases the lead time to getting a new device if it doesn't fit right or if some minor tweak needs to be made. And then just the customization aspect, we can create really cool designs that can't be manufactured in the traditional way. We're applying much more engineering to it, where we're looking at lightweighting with lattice structures, variable thicknesses, and then even adding, structural components that will strengthen the device without adding too much bulk. With our Quattro socket technology, the traditional fabrication, was very labor intensive. You're either cutting and polishing and grinding on carbon fiber, which is, can be dangerous. And with the digital design and workflow, we print it and we have a finished product. There's not too much post-processing to do. And it's a lights out fabrication process. So, we hit print, come back the next day, and it's done without having, staff putting labor and hours into it.
Oh, that's great. And you mentioned about printing some complex geometry parts and then having like lattice structures. And then do you receive any feedback from patients that, considering the complex geometry and then customization, so regarding fit and comfort, what's the feedback that you usually get from patients?
Yeah, we're seeing that, a lot of our patients are saying this is one of the most comfortable and form-fitting socket that they've ever had. And with this material and the ability to create these complex lattice structures and things like that, and using, different TPU and the PA12 nylon plastic, we're getting cases where people are getting increased proprioception, so they're able to feel, where their limb is in space with the lattice structures, because it kind of flexes with them. As they take a step, that compresses the lattice structures that we design in our compression zones, and then as they offload into swing phase, that lattice kind of pushes back as their muscles relax, so they're getting this constant feedback in throughout the gait cycle. And so we're getting, a lot more confident customers, and again, increasing that proprioception that just leads to overall more acceptance rates with our devices.
Oh, that's interesting to hear. Antonio, could you share some of, on the same line, about talking about, the benefits of what the benefits that MJF is bringing to Hanger, considering, for example, customization, being a more patient-friendly process. If you could share any feedback from patient, and also how additive manufacturing is helping you to develop more complex parts.
Yeah, I'll echo what Sean said. We've had patients come back and say that's the most comfortable fitting socket I've had, and I've been an amputee for 15 years. I think for us, one of the aha discovery moments was we don't have to make this the same thickness. We don't have to make this conventional like we used to. Let's start varying thickness. Let's start targeting ways to have energy return where we want it. Let's target areas that aren't comfortable for a patient historically, and let's make it have a little bit more flex here. With digital tools that are available, we're doing finite element analysis on these structures and really targeting what we believe will make it comfortable to a patient. Not only that, we can look at energy return and say, how do we improve this device's function based on the parameters that we now have control over? We can target thickness, anywhere in that shape, change cross-sectional areas to improve flexibility, whatever it may be. We've done that. We looked at integrating hardware into these devices to make it lighter weight. You no longer have to think of the same, Mr. Potato Head assembly. You can build it how you want to build it. And so it's just that freedom that we have and how fast we can conceptualize and go to design and try something for our patient. And then, as Sean also mentioned, we have that digital record. We can go back and take that knowledge on what worked and what didn't work and start to build that understanding of, here's how we make a better device going forward, because we know those parameters that went into that. And with our patient volume, it really helps us start to define those parameters that make a better device.
Okay, that's interesting. And Diana, I'd like to get your perspective on this as well, considering some of the benefits like complex geometry, customization, and a better fit for the patient.
Yeah, absolutely. So with fracture care and with acute injuries, like when you have it post-surgically for pins or incisions, there are a gamut of different technologies that doctors can now use because they have the ability to custom design every single device. With traditional casting, it's just some plaster or fiberglass in your closet and you put it on the patient. You don't have a lot of technology options that you can use. With ActivArmor, you can use a TENS unit for pain management to reduce opioid use. You can use a muscle stimulator to reduce the amount of therapy you're going to need post-healing. You can use bone stimulators. Adam Chantrello, the motocross racer, used an ActivArmor specifically so that he could heal in half of the time using an ultrasound device on his fracture and get back to his sport. So the ability to be able to expose pins or incisions for observation or treatment, be able to see the wound and treat it, the skin, and make sure that if there's any swelling coming up or down, you can see it and adjust it. That's things that you just can't do with old school technology, and with this you can, and that's part of the lattice structure, the ability to see and treat the skin while you're being immobilized, and the custom design ability so that every doctor can provide precision care for their patients, since every patient is different, has different lifestyles, different needs, different injuries, and needs different support.
Okay, great. And then besides the complex geometry design parts, customization, what other benefits you see, Diana? For example, lead time reduction, or reducing rework, reducing human error, or even on cost reduction compared to the traditional process. If you could comment on some other benefits as well.
Sure, absolutely. So I'll start with the cost. The one thing about the cost is that traditional casting and splinting, it requires a lot of cast saws where they're scary and you have to cut them off and reapply them in order to ensure compliance. With this technology and with thermoplastics, you have biocompatible materials where you don't need to have padding that will trap moisture and bacteria against the patient's skin and then need to be adjusted, like cut off and reapplied to be adjusted. With this technology, you can have one device that you reuse, make adjustments to, and then it can even convert from a cast into a splint. So it's going to save a patient that may have 2 or 3 casts. They may have to go back in to get it sawed off and reapplied because it's soggy. All of those things you eliminate with this. So it saves the patient money, it saves medical waste, and it saves the clinic money as well, as they can just, print one plastic device. It's just as inexpensive in materials, and it can be reused, so it saves all of those. So, in as far as the flow, same thing. You're saving the clinic the staff time where they're doing a 1-minute scan and then just popping a device on the patient, as opposed to all of the getting the water out in the plaster and applying it and letting it dry and then sawing it off and opening it up and checking the skin and reapplying it at every exam and x-ray. So those are some of the both patient and clinical benefits of this technology.
Okay, great. And Antonio, if you could give your perspective on some other benefits as well.
Yeah, I mean, Diana touched on a lot of the waste savings. We're not shipping casts. We're not waiting for that delay time. It's instant. They scan a patient, it comes over to us. So that's a big one for us as well. Also, I'd mentioned if a patient ever loses a device or something doesn't go right, we can quickly react to that and produce another one. And you don't have all that up front of recasting cost and doing it over again. And the final thing I would say is that initial, first fit impression that we get, and that success, and the ability to communicate if it wasn't right. You just make this small change and we have that digital record to do so. That definitely saves the patient making 5-6 trips to the clinic if we can hit that right the first time or the second time. It definitely saves a lot of time for the patient. So it's cost, time, and just the ability to be more dynamic.
Mm-hmm. And Shan, you see the same benefits at Quorum? If you could share a little bit more about that.
Yeah, you know, just echoing again what Antonio and Diana has said. One thing that we see too is that with this technology, we're able to fit, upwards of four BK sockets in one build, or upwards of like 2 AK sockets in one build. And so, and that print time is the same no matter how many parts you fit in there, right? And so, in the 16-hour print time, we can produce up to 4 BK sockets or up to 2 AK sockets, and so that really reduces the labor and time costs there. And then we're just limited to design time, and so having that capability of creating 4 sockets in 16 hours is really beneficial.
Okay, that's great to hear. And then you guys already talked about the patient acceptance that is in general really good. They are really enjoying the experience of having a better fit, a more comfortable part. But what about the provider and the doctor acceptance? And how do you decide between a traditional or a 3D part? We can start with Diana.
Sure. So one way that you might decide is when you have a 3D printed part, it is, in our case, it is not remoldable to the patient. It's more of a, you do a scan and you create a part to them. So in one way, this wouldn't be the first healing phase for someone who has a lot of edema or who has a displaced fracture who needs to be reduced into the device. So in those cases, you might use a traditional fiberglass cast and then transition into this a week later. So that might be one decision you might make. But for any patient who has any sort of skin issues, elderly patients with thinning skin, a diabetic patient, anyone with eczema or who has allergies or strong reactions to some of the casting and splinting materials, or a kid who just wants to go to the beach for their summer vacation, or someone who is in food handling or in healthcare who needs to sanitize their hands while they're being immobilized and is out of work. Workers' comp loves this type of product. So that might be a way that you would make a decision and for that. And I would say that our providers, the ones that treat athletes who really want to be able to sweat and train and not have your entire arm in a club in a cast, but instead immobilize precisely just the parts that you want immobilized and not the rest, so that they can continue with their active lifestyles. That is one of the ways that a provider might say, hey, might suggest it and say, hey, this is a perfect product to you. And it just really does improve the patient's quality of life while they're healing. So if you want to improve your patient satisfaction rates, a product like this is great, not to mention the marketing opportunities, because we put the clinic logo every single device. So the patients kind of go out and are walking billboards for the clinic. So those are some of the reasons providers like it.
That's great to hear. It's free marketing. It's interesting.
Right.
Yeah. And then Shan, I'd like to get your perspective on that, on like how do you decide between a traditional or 3D, and also at Quorum, what's the provider doctor acceptance as well?
Yeah. So we have multiple clinics here in Windsor, one in Denver and one in Cheyenne. And we've worked with several other clinics across the United States, in several other states, and the doctors really like them, and the one benefit would be if we can. They tend to shift towards the 3D because they see the capabilities of it, and the customization and the complex geometries and designs that we can get. And so kind of comparing like whether you go with a traditional socket or a 3D printed socket, it's the added features that you can get out of this technology that push people towards a 3D printed socket. like adding, BOA dials and adjustments and different features like that that add to the functionality and also the aesthetics. Again, like Diana said, it's you can add marketing, you can add tons of different personalization to the device that this patient is ultimately wearing. And so sometimes we'll even bring in patients and they'll have input on, what their socket looks like, what different features they can add, things like that. So it gets them more involved in the design process of the device that they're going to be wearing. So, but if we've had certain cases where we just couldn't do 3D, and that's just limited to build size volume. So we've had knee disarticulated sockets that just wouldn't fit easily into the print. So that might be one reason to go with a traditional made. But really, it's the benefits of the functionality and different custom designs that you can get out of this technology that really attract the practitioners and patients.
Oh, that's great to hear that, besides the patient, you guys are also having really great acceptance from the doctors, from the providers. And Antonio, I'd like to get your perspective on this as well, your experience with the providers, the doctors, and then the decision between traditional versus 3D, how you handle that.
Yeah, I think the feedback I've heard from the docs is they like the technology. They think it's interesting. They think it's neat. But probably the best feedback I've got was from a patient who was a child of a physician, and we made a custom application-specific device, and he loved it. Then he came back and said, "Hey, this is great, but my son has gotten bigger." And I said, "Okay, well, let's scale it." With the digital tools, I was able to scale it. And they're like, "No, this isn't gonna. We're not sure if this is gonna work." He tried it. It fit perfect. It worked again. I printed 3 in one go for really no additional cost, and sent all 3, and he was pretty excited about it. As far as who gets, who decides or what patients, what applications this technology is good for, I advocate for the safety. I look at, is it going to be safe enough for the application? But in all honesty, I leave it up to our clinicians. They see patients every day and see a bunch of patients, and they're the experts. If they say, "I want to try a 3D printed device," then by all means, I'll support it and help them. But it's their call at the end of the day.
Okay, I see. So a last question before we go to the Q&A. So we have some time for Q&A after that. Antonio, I'd like to get your perspective on how do you see the future of additive manufacturing on the medical industry. So considering, more applications, different materials, technologies, how you see this growing within the medical and especially the O&P industry?
But it's definitely, to me, going to be the future. As the technology advances and you can print different materials, you start to print more and more of the device altogether, and I think that's going to be huge. And as the design technology, the CAD and the digital tools improve, you start to be able to automate that whole process. So you take something that a few years ago, if you were to look at a customized device and say, "I want to start this and design it start to finish and get something that's unique and a one-off," that was pretty time consuming. But as those digital tools improve and things improve, and even getting stuff to the HP printer, as that improves and the nesting capabilities improve, it's going to make it so much easier to get that device conceptualized, designed, and done, that the volumes and the scalability will be there. I think it'll be the future. It's going to be a better, more comfortable device for the patient, because it can be more targeted. It can be application specific, without any extra effort. And that today requires a lot of extra effort if you're laminating something to make something so you can attach it to a bicycle or a golf club. You're having to find a component and makeshift something to work. But I definitely think it's going to be exciting in the next couple of years. We should see a lot of improvements.
Yeah, for sure. And Diana, what's your perspective on the future of additive on the medical and especially on the O&P industry?
Absolutely. I think, to be honest with you, that additive manufacturing and custom mass production is going to be the future of all manufacturing in the United States. We obviously are not going to try to compete with China on mass producing millions of standard widgets cheaply, and I don't think we need to. What we have right here is direct access to the American consumer and to the patient. And as you know, in medicine, there is no one size fits all option for people. We are all shaped different. We all have different needs. We all have different unique injuries or conditions, and we all have different lifestyles and activities. And I think that medicine and medical devices should be precision medicine. They should be patient specific. And I think that's the future. And this technology is enabling that future.
Oh, that's great to hear. And Shan, if you could share a little bit more about your opinion on the future of additive in the medical industry.
Yeah, I'll just echo a lot of what Antonio said. Is as the technology advances and there's more material options and things like that, it's just going to propel this further and faster. And you know, right now we're in a really good place with it, and we're creating a lot of really cool and dependable stuff. But as you know, as the software develops more and it's more accessible to the global scale, then you know it's just going to keep advancing from this point on.
Okay, great. Yeah, so I'd like to thank you all for the panel here. Now we will invite Kenya back to our discussion because we'll start the Q&A section. Kenya, feel free to join and start with some really interesting questions that we received.
Yeah, we have quite a few. So the first question for the group is, how do you tackle alignment transfers when you're going from a test to definitive printing of a socket?
We can start with Diana.
I don't print sockets, so you better skip me.
Okay, good. Shan?
Yeah, so transferring alignments, you know, I've done it a couple of different ways. Sometimes I'll work directly with the provider, the practitioner, and kind of share my screen. And if they have, you know, their alignment in mind, I can adjust it on my screen and they can, you know, see it and confirm it. Another way that we've done it is scanning the diagnostic socket with the alignment and everything on it. And, you know, if the practitioner created that check socket with it perfectly aligned where they need it, then we can directly duplicate that really easily from the digital scan. And I think that's mainly what we'll do there.
Great. Antonio, if you can share a little bit about that.
Yeah, you know, we've been somewhat down the same path. We would print a diagnostic socket and scan over that, or we'd do a traditional fabrication and scan over that. But you know, as with, not to take away from HP, but other printers that can print translucent, you know, there's no reason why we can't print alignment hardware in that socket and start to use that to gauge, because we still have that digital record of what we printed, and we can use offsets and different ways to kind of work through it without giving too much away. It's kind of some tactics we've taken.
Okay. This message, or this question, sorry, is specific for Diana. Is there a way that any O&P shop or clinic can adopt the ActivArmor turnkey process and offer them in their community?
Yeah, that is why it is so awesome to have this digital workflow, because now anyone can do it. And so all they have to do is contact us, and we come over there and give them the equipment, and they can launch it there. They can either do the manufacturing there, or they can just place the orders there and we can get them shipped to them. So yeah, it's available to anyone. So give us a call. We're at activarmor.com. Great,
thank you. So for people that are currently printing in the fused deposition modeling, or FDM, and in a large volume, but are considering transitioning to multi-jet fusion, or MJF, what training programs or courses does HP specifically recommend to get started in this space?
Okay. we can start with Sean.
Yeah, so in our experience, we started out with FDM, just making different prototypes, things like that. But then once we acquired our machines, HP actually came out, did a lot of training with us on how to use the technology, how to maintain the machines, operate the machines. So HP directly has a lot of really good resources to start using it if you're planning to go in-house. If you're not planning to go in-house and want to start, experimenting with MJF, like what we did is we outsourced a lot to other suppliers that supplied MJF parts. The biggest thing would be to really dive into the design for additive manufacturing, because different technologies, printing technologies, and different printing processes require different designs. And so like with MJF and the powder bed system, you don't need supports, you don't need certain things that FDM would require in the design, but then other things like, powder expulsion. So for our design, we have all these pipes that run the BOA system. You have to be able to clear that residual powder out of those lines. And so you have to design a way for that powder to escape. So it's different things like that. And there's plenty of resources online. And I think HP also provides some handbook on design for additive manufacturing using their technology.
Great. Diana, any comments on if you have any experience with using other technology and then comparing with MJF?
Yeah, it's so funny because there are such a wide variety of different materials that you can have with the different technologies. I mean, we use a whole range of different 3D printing tech, depending on what product we need and what materials we need to use, and what finishing process we have, and what they're going to, do they need to be strong and thin, or do they need to be do they need to be able to be solvent finished, or do they need to have a coating, etc. And so it's really nice to be able to have that variety. And when you do shift from one tech to the other, and that's the thing about these turnkey processes, is it's really nice to be able to have a package of the digital workflow for each type of product that you need for each different use case. And that's what we develop too, is you have one specific target in mind, you develop a whole digital workflow system perfectly just for that, and then you have another digital workflow system with a different hardware and software that you can use. So HP has been very helpful in helping us transition and learn all of the key aspects of how to make MJF printing work well for your specific design.
Okay, great. And before we finish here, Antonio, would you mind sharing your experience as well, like with MJF compared to other technologies, and then like the benefits that HP is bringing?
Yeah, so as Sean mentioned, HP has a really good training program. They sent out a tech for a couple days, showed us how to fully take care of the equipment, how to make sure it lasted, tips and tricks. There's a knowledge base online too. We could look up articles. We also had a really good, HP distributor. Anytime anything goes wrong, I can get either HP on the phone and they can try to troubleshoot remotely. I'll have the distributor come out if anything's happened to the printer. Respond really quickly and really helpful. And a lot of times it's a quick phone call. The technology, surprisingly, it looks complex on the outside, but with their troubleshooting, they simplify it and make it easy to fix it. So a lot of the issues we can fix on our own. And just getting started to use it, it wasn't, once you get past loading and all that stuff, that's different than we expect. It's kind of like using a desktop printer. You send your print and you hit go, and next day you got your prints done. So it's been pretty straightforward to use.
That's great to hear.
All right, so thank you all. This is going to conclude our Q&A section of our discussion today. Fernando, Diana, Sean, and Antonio, thank you all for a really terrific discussion, certainly for your time for today's webinar. I'd also like to extend a thank you to all of our attendees for your interest and your time in our webinar. And to those of you that are also our COPA members, we see you and we are so thankful for your continued support. Check our website, californiaonp.com, for those COPA updates and the announcement for our next webinar. Fernando will have a couple things to add, but I wanted to say thank you and I hope you all have a really great day.
Perfect. So first of all, thank you, Kenya, and thank you, COPA, for all of your help. It was a great experience. And a special thanks to all the panelists. So Diana, Shan, Antonio, thank you so much. And I'd like also to thank all of you for attending this event and invite all of you for next OMP event that HP will be hosting next week on January 26th at 11 a.m. Pacific time. I will share the link here with all of you. And this event is a virtual tour on our demo center. So we'll talk about how the technology works, some overview on the 3D printing end-to-end workflow, also showcase for some OMP applications, and then a session of Q&A. So thank you all for attending. It was a really great experience, and thank you again for the panelists.